Welcome. Thanks for coming to CON322, all in on AWS Fargate for high security workloads. I'm Rafael Segura. I'm a solutions architect with AWS, supporting Vanguard. And today for this talk, I have here with me Akshay Ram. He's the product manager for Fargate. And I also have Ioni, chief enterprise architect at Vanguard. On this talk today, we're going to talk about thinking big, taking action, and going all in. And let me tell you a story that exemplifies that. Around this time of the year, reInvent 2018, around this time last year, Ioni reached out to me to discuss the container platform and the container deployment at Vanguard. They were using a third-party container orchestration platform, but they were looking for a new platform that they could provide more cloud-native capabilities. So think about things like elasticity, lower management overhead, and more cost efficiency. So we started discussing how they could leverage ECS and Fargate and all the benefits that comes with it. But of course, there was also a challenge in place. Vanguard have very high security requirements, as you would expect from one of the world's largest investment companies. So we had to go through the process of getting ECS and Fargate approved and validated for security to run production workloads. But as I said, this talk is about going all in. So as you can imagine, fast forward 1 year, success. We're here telling you about the story on how we're able to use the new features that Fargate launched with ECS, but also all the hard work that the team at Vanguard put in place to make sure the platform was compliant to their requirements. So today we're going to share this story, and we really hope that helps you in your company to also accelerate the adoption of Fargate. So let's get started. To cover that, we're going to be talking about Fargate adoption, how the process usually goes. New features we're launching Fargate. We launched it through these years. A lot of things we're launching here, reInvent. We're really excited about sharing these new features with you. And Ioni was kind enough to share the story on how they deployed Fargate and how they customized Fargate at Vanguard. So let's get started. To understand the Fargate adoption or containers adoption in general, it's useful to understand, to see how different teams inside the organization look at this new paradigm of adopting containers. First of all, the developers. Of course, they're always excited. They love the elasticity that Fargate provides. They know that with containers, you can get your code much faster from development to production. So it's all good in there. The architects are also excited about containers. Now they have an option to match the microservices architectures that they design to the container deployment model. So that those two things match really well. So they're also really excited about adopt containers. The infrastructure team, they have some questions, right? They start thinking about deploying containers. Now they have to think about managing those clusters. They understand that deploying one container in one laptop is an easy task, but deploying and managing thousands of containers in productions, it requires better planning. Same thing happens with the CFO or the budget team. They know how to use things like reserved instances and spot instances on EC2. But how does that translate when we're talking about containers? And of course, they want to get cost-effective running those platforms on AWS, right? Same thing with security. The security team, they know how to secure the EC2 environment. At runtime, for example, they use things like agents to do monitoring. But how does that translate to the container environment, where ideally I will not be running any kind of agents, right? This principle doesn't translate to the container environment anymore. How can I make sure only validated images run on my container environment? So all those questions comes into play, and we need to go through those to address those questions to, as I said, to validate and to get a container approved for usage. So enters AWS Fargate. So Fargate helps us to address all those questions about management, about cost, and about security. As I said, some of those things are based on the new service features we launched. Some of these things are based on customizations that the customers put in place, like Vanguard. So to understand how Fargate helps, right, that's a blank statement. Fargate helps with that. To understand how effectively Fargate helps with that, let's take a quick recap on how containers runs on AWS in managed platforms. So if you look at the managed container platforms we have at AWS, we have an orchestration layer. And the task of this orchestration layer is to, as the name says, orchestrate how containers got deployed throughout your AWS infrastructure. We have services like ECS, Elastic Container Service, and EKS, Elastic Kubernetes Services. They are the core service for this type of orchestration. These services, they remove the heavy lifting and they enable you to run the orchestration without having to manage the servers behind it, where I have to worry about patching and upgrading. We also have services like ECR that offers the repository where you can create private repositories and lock them down and have specific networks connectivity to those repositories. So that also helps with the security requirements. And once you have the orchestration in place, now the whole idea is that you can just make one API call, pass a task definition, and you're going to have your containers running, your tasks running. But your tasks and containers, they need to run somewhere. So that's where the runtime layer comes into play, right? So together with the orchestration layer, you also need a runtime layer. On that runtime layer, you can have a cluster of EC2 servers that you're gonna manage and size and provision. But you also have an option to run that runtime layer with Fargate. So that's where you start to see the benefits of Fargate. Right? With Fargate, we bring a serverless operational model to the runtime to run containers. And what I mean by that is now that you don't have to size or manage or provision those EC2 servers anymore on the runtime layer. You can just use, as I said, it's a serverless platform, so that implies that you're not going to pay for idle resources. The platform is going to scale up and scale down based on your requirements. And you, as I said, just pay for what you use, and you have embedded high availability and resiliency. So again, that highlights the benefits of Fargate and why so many customers are choosing to use Fargate. So all of that comes, the whole serverless benefits, and they come without compromising the things I was talking about, what the developers and the architects love, right? So for example, with Fargate, you're still going to use the same container. You don't need to do code changes to run those containers in Fargate, whatever containers you have today. Fargate also provides security. So if you think about compliance, you can architect your applications to be compliant with things like PCI or HIPAA compliance, for example, by using the service. And also, another interesting point about Fargate is that by opting for the serverless operation model, you do not lose the integration with other AWS services. So Fargate allows you to integrate with other AWS services so you can create powerful and complex applications using the combination of the services. So think about services like load balancers with networking, with service mesh and service discovery, logging, monitoring. So all of that works really well with Fargate. So to give some two examples of this type of integration, how those integrations helped Vanguard to adopt Fargate, I'm going to talk about the integration with identity and access management and the integration with network with Fargate. Again, there's much more than that, but just let's focus on those two examples. Those are very critical. Talking about identity and access management. So with Fargate, you have total control about the IAM permissions that are assigned to your task and your cluster. But what does that really mean? What am I controlling with those permissions? First of all, you're controlling the cluster. You have control over the cluster permissions, and that means you control who can run a task inside your cluster. Which IAM role or IAM user can start a new task on that cluster. So that's the first level of control you have. The second level of control, very important, application permission. That's a different type of permission. And what does that mean is that now you can control what services this task is able to access. Is this task able to access a specific DynamoDB table? It does have read or write permissions. Does this task have permission to access an S3 bucket? And the list goes on and on of the number of services you can control access to, right? So that's the idea. The third type of permission that you also have control is about the housekeep permissions. So think about housekeep are all those tasks that exist for the task and the cluster be able to run with the containers deployed. So if you're going to need to pull some image from ECR, for example, you're going to push logs somewhere, you control which repositories you can access, you control which CloudWatch logs you can push or to specific topics you can publish. Another type of control, it's a data plane level of control. It's control about networking. So now that I'm running this task in the serverless environment, it does not mean that I'm going to lose the control over the network access, because my tasks are going to be spun up and run inside the VPC and the subnet you select. We call that AWS VPC mode in our documentation. So that means the task is going to have an IP address that belongs to your IP address space. And it's going to have the same level of isolation and features that the VPC provides. So think about things like exposing your task as a service to the internet behind a load balancer, right? So that's supported. You can privately and securely connect to other AWS services inside your VPC. So things about databases or any other service that's inside your VPC, it's going to exist in there. You're going to control also for everything that you need to talk outside your VPC. If you talk about security, high security workloads, you want to have that connection private and secure and control it by you. So you can use things like VPC endpoints. VPC endpoints allows you to have this, as I said, private secure connection to services like ECR, where you're going to pull your container image, KMS, where you're going to pull your encryption keys that you're going to use for security, and many, many other AWS services. Other type of connectivity you might want to have is to talk to another VPC, a different VPC, so your container can use things like VPC peering or transit gateway to do that, also secure, also encrypted. Same thing going back on-prem. You can leverage tools like Direct Connect or VPN connections to do that connection, and your application can access the resources back on-prem if that's required. So with all of those controls together, and many others that Ion is going to talk about, you can see that Fargate allows you to enable the serverless operational model, but at the same time be very secure and have total control about the security posture of your container platform. So to give more detail also about the new features, I spoke about what's out there today, but to talk about the new features that we launched here at reInvent, I'm going to invite here on stage Akshay Ram. So Akshay, the floor is yours. Thanks, everyone.
Hey, everyone. My name is Akshay Ram. I'm a product manager with AWS Fargate. So as Rafael was mentioning, customers are starting to think big on Fargate to really leverage that operational model. And we can actually see this in our metrics. 40% of new container services products on AWS, so customers who are new to container services, choose Fargate first. And that is because of us adding new features over time and making it more powerful in terms of being extensible and allowing this concept of security by default. And this can also be seen by a diversity of use cases with customers. Typically, serverless was with a lot of event-driven applications. We see that a lot, but we're starting to see growth from a lot of embarrassingly parallel genomic processing jobs on Fargate. That's catalytic data sciences who runs parallelized applications. And we have customers like Samsung who run long-lived applications. They just run on Fargate. You don't maintain, you don't patch those instances. It's completely serverless. So they just keep running and serving requests. And for you, it's zero maintenance. It enables this no-ops way of running applications and helps you run in a very lean operational fashion. So as we ask customers, what else do you need? What do you want? What else do you need to go bigger on Fargate? And are there any gaps or features which we're missing? It essentially fell down into 3 specific categories. What does it take to go all in was the question we asked them. One is pricing. So the customers were happy with the Fargate price. In Jan of this year, we dropped our prices by 50%. And it made us highly competitive because VMs are, containers, the Fargate configurations you choose are smaller than VMs, so you actually save on the cost of not utilizing your VMs. The second is they asked us about extensibility over their observability tooling. So the customers had, clearly the observability space has a lot of selection, and customers wanted that extensibility point on Fargate. And lastly, this is not a feature per se, but customers wanted clarity over what it is, what is the security posture on Fargate, and what is this, so we have this concept of security by default, is what do we offer out of the box in terms of how we harden every container that runs on Fargate. So let's start with pricing. So this is our containers roadmap. We have the AWS Container Services team has our roadmap public on GitHub. So if you have any feature requests, you can always create an issue there, and we're always listening. So customers were saying, hey, we love the serverless benefits of Fargate, but we miss something with VMs. We miss the ability to use Spot. So they use EC2 Spot instances today, but they wanted to use it on Fargate. And they also wanted, when applications run continuously, they're always running this. So there's no scale out and scale in. And as I was saying, there was many customers who like to run long and long-lived applications. So they're like, can we have like a discount model similar to the EC2 RI pricing model on Fargate? So when we actually dug a little deeper, we thought, we wanted to marry two worlds in terms of having VMs and capacity and spare capacity with Spot and reserving capacity versus serverless, and how do we make those two worlds meet? So this year, we launched 3 significant pricing innovations. As I alluded to earlier, we invested in technology that makes us more efficient, and we dropped our prices by up to 50% in January of this year. And it was investments in technology like Nitro and Firecracker that helps us be more efficient and pass on cost savings to customers. It is compute savings plan, and this is super friendly and it's super. It works well in a serverless way because you don't compute the compute savings plan, which I'll get into any detail into detail a little later. Is that you don't have to commit to a specific instance type. You just commit that I'm going to use compute at AWS, and you can use any sort of compute option you want, whether it's EC2 or Fargate, and you get discounts. And this is hot off the press in that we just launched this yesterday as Fargate Spot. It's the ability to get Spot-like discounts on Fargate, but you don't have to deal with the managing of instances and infrastructure. It's all completely serverless for you. So that's where we really try to figure out how do we get you the best of both worlds, fulfilled through a serverless operational model. Let's take a look into some of these in a bit more detail. The first one I said is compute savings plan. So you get up to 50%. It's 1 or 3 year commitment. This is the similarity which customers wanted. They said, make it similar to RIs. When we asked customers how would they like it, they said, make it similar 1 or 3 year commitments, and you get up to 50% discounts. It is super migration friendly. I think this is a really important point in that we understand and recognize that customers always have some EC2 and they'll have some Fargate, and there'll always be a state of migration. And this could vary by a business cycle. It could vary by your needs of being on a specific instance type. So you actually commit at an AWS level. So you get flexibility to use EC2 or Fargate, and you get discounts across the board. So wherever you go, your discounts follow. Wherever your usage goes, your discount follows. So it's super migration friendly. And the third is you get built-in recommendations in your Cost Explorer. So we actually make it super easy for you to avail these discounts. So if you can go to the Cost Explorer, you can see based on your past usage, what is a recommended savings plan to buy to help you avail savings for your applications. The second innovation which we launched on pricing this year is Fargate Spot. And this is up to 70% discounts. This is for your applications that are interruptible. It could be your ETL jobs. It could be your embarrassingly parallel jobs. And it's typically for the applications that run on EC2 Spot. But there's a little more here. We made it migration friendly. We didn't want our customers to go through too much re-architecture to use Fargate Spot. If they wanted to run their tasks on Fargate or Fargate Spot, there shouldn't be too much of a rewrite. So we use the SIG-term signal, which customers use today to clean up their, it's a standard signal to perform cleanup operations. So we give you that same signal, and you can use up to 2 minutes to do your cleanup operations. And 3 is, I think this is a really important point, is you get application-first controls. What I mean by that is on Fargate, you have no cluster. I mean, the cluster on Fargate is a namespace. So you can say your web application team can now mix Fargate and Fargate Spot. And since there is no back and forth between 2 teams, it's just the application team who controls how much he or she wants to mix between Fargate and Fargate Spot. They get clear decisions as to, because they get feedback through cost allocation, that how much am I willing to put on Fargate and how much am I willing to put on Fargate Spot, such that I can leverage those discounts. And hey, if you want to be really conservative and run a lot on Fargate instead of Fargate Spot, you can always buy savings plan and see cost savings as well. So combined, I think Spot and savings plan work together and really help you leverage cost savings as you use Fargate. And we will try to address some of our customers' requirement to give us their similar levers which they had with virtual machines. The second big pain point customers wanted us to solve was observability. When Fargate launched in 2017, we had support only for the AWS logs driver, which essentially meant that you could send logs to CloudWatch. But we soon learned customers had integrations with partners like Splunk, Datadog, Sumo Logic. They had built custom ingestion pipelines like an ELK stack, or they use Kinesis Firehose and Kinesis data streams to transform logs. So they wanted to migrate those applications over, and this was adding friction because we didn't have that extensibility. And the second is they wanted native support for deep visibility and metrics. This is a common ask because customers want to understand what is the resource utilization of their tasks on Fargate so that they can right size and auto-scale the right way. Let's jump into logs first. We just shipped FireLens for logs. This was actually shipped, I think, a couple of months ago. It is essentially one interface to send logs to anywhere. It fulfills the ask for extensibility of customers. It's built on open source technology, which I'll speak about in the next slide. But it essentially gives you a native integration to send from, let's say you want to send to Datadog or Splunk or Kinesis Data Firehose or MSK or CloudWatch. It just enables you to say, I want to send it here, send it there, and you don't have any intermediate hops or intermediate code to maintain to send logs to the destination you want. It's quite extensible. It also gives you levers to reduce costs. It's built on open source technology that has a lot of filters which allow you to send some logs to S3, and you can index them later through Amazon Elasticsearch. There's a This Is My Architecture talk by Ancestry which says, let me send all my logs to S3 and pull them on demand to Elasticsearch. So you have that levers to tune between highly available search versus storage, and gives you that cost optimization levers. And it also decouples. We've also built it in a way that decouples log ingestion pipelines. What I mean by that is you can separately, independently configure. This is an ask by many of our customers, that they have separate log ingestion teams versus separate application teams. So the log ingestion teams wanted to control the configuration independent of the application, and you can do that now with the interface of FireLens. Let's take a look let's take a look at how it looks. So this is your interface. You use a log driver called AWS FireLens, and you can specify any destination you want, be it Datadog, Sumo Logic, Splunk, Kinesis Firehose, as I said, AWS, an AWS log analytics storage tool or a partner tool. You can specify secret options to configure your driver, could be mostly your API key. And this is something which we worked with the community of FluentBit. FluentBit is a CNCF open source project where this is a container image which you have to run as a sidecar with your application. And this is the image which has the plugins to all the destinations you want to route to. And this we work by contributing and asking our partners to contribute to this community. So this is how the interface works. It's super simple. You can try it out today. And we also have a detailed blog post as to how much overhead, because customers said, hey, it's a sidecar. Or we care about overhead. What is the overhead of this? It's super light. It takes, even at high log volume, it takes up to 50 MB. So you can check out. We have blog posts on this. I can share the content of that later. Lastly, customers ask us for metrics. Metrics is something which is super critical. It's like air, food, and water for customers to understand what their tasks are doing. So we launched Container Insights for metrics, where the interface is even smoother than Firelens, because it's essentially built in. You click a button and it just works. And also, you get deep dive. You get a deep dive into all your application data, because it's integrated with log insights. So you can run structured log queries against your metrics, and it's actually the data center structured logs, which we then parse to metrics. And you can always run queries on the structured log. So you can really parse high cardinality data right up to a container level, and it's available out of the box, and it's also super competitive on price. So this is how a dashboard looks. It's ready. It's GA. It was launched sometime around the New York Summit, so you can check it out and give us any feedback on the roadmap if you want us to add more to it. Finally, this is the Fargate security model. And this is, I'm pretty sure, why most of you are here, to understand how Vanguard actually used, how benefited from Fargate to reduce their operational overhead. So Fargate, by default, offers every task with a full VM isolation boundary. So you don't have to worry about container breakout. It's part of our design. And every task gets its own isolated CPU, memory, storage. And as Rafael said, you have credentials isolation. And you also have, this is a big thing for customers, is hands-off patching. You don't have to actually patch the hosts. It's completely, because it's serverless, we do everything behind the scenes for you. So you don't have to worry about armies and which army versions, which CVEs, patching. It's pretty seamless for most part for customers. And we have multiple customers, if you search about Fargate security, who reference that it's been super simple for them running on Fargate and not having to patch instances. So to elaborate more about this no ops model or less ops model or ops where you want to focus on model and how Vanguard benefited from security of Fargate, I'd like to introduce Yoni. Thanks.
Thank you, Akshay and Rafael. My name is Yoni. I'm enterprise architect in Vanguard, and I would like to share our journey into ECS Fargate from the last year, like Rafael illustrated. Before that, quick introduction into who Vanguard is. We are one of the largest financial institutions in the world. We are located in Malvern, PA, strategically located between Wall Street and US East 1 data centers. We started operation in 1975. We have multiple lines of businesses, institutional, retail, and a new one that we are rolling out is advice. What type of application we are running on ECS? We started with web-based applications only. So they're long-lived applications, usually fronted by a load balancer, an ALB or an NLB for web-based, most likely ALB. And recently, probably about 2-3 months ago, we started exploring batch-based applications to run on ECS, primarily for those use cases where Lambda wasn't a good fit. We chose ECS Fargate for a variety of reasons, but some of them are on the screen. It's really fully distributed architecture. It enabled us to implement DevSecOps patterns or ops patterns, depends how you like to look at it. And by that, I mean to isolate the ownership of the entire stack just to one team. They can deploy things, and by deploying those things, they do not affect any other team. So that was a big deal. The solution was backwards compatible with the legacy container orchestration that we had until we started using ECS Fargate. It is fully automated and automatable. Like Akshay said, it's secure by default, one of the most important things for us. It is cost effective, and by that I mean it is more cost effective than our existing legacy solution. And the last point is probably one of the most important ones as well, is that it enables a no-ops pattern. And I will elaborate on that in the future slides, but it reduced our operational frequency dramatically, almost to non-existent. So I want to cover our web-based architecture a little bit, the stack that we have. Our idea was to create a highly parameterized CloudFormation template, a single CloudFormation template that any application development team in Vanguard could use with the right parameters for their application to deploy their stack, and those are the components that would be deployed by that CloudFormation template. So obviously we have Amazon Elastic Container registry service where the images are being pushed. Fargate is the compute platform. We didn't even look at EC2, even though that was available first. Amazon Certificate Manager, AWS Certificate Manager is another thing that we brought in along the route. We didn't talk much about it, but it is a service that enables us to have less operational frequency. And I will talk a little bit about that service just because it's very pertinent for our discussion. ACM will issue certificates for free to any AWS property that can handle ARN-based certificates. Basically, it's a certificate that you don't have an access to the certificate, you just have an access to an ARN. And that ARN can be associated with a load balancer and other AWS primitives that support it. But what's more importantly here is that when time comes to rotate the certificate, as long as the certificate is attached to that property and the validation record for domain ownership exists in a public zone, AWS will seamlessly rotate the certificate. There's nothing else you need to do. And speaking about Route 53 zones, the load balancers in this architecture are primarily internally facing. So their resolution is happening for private Route 53 zones. But the validation record that ACM issues in order for them to validate the ownership of your domain is residing in a public zone because the service comes from the internet and needs to resolve it in a public zone to validate ownership. Everything is encrypted in motion in this implementation. As I said, from the ALB side, the traffic comes in and it's encrypted with TLS from ACM. The connection from ALB into ECS Tasks, by the way, we have 2 by default as a minimum so that they deployed in multiple availability zones, is encrypted with the privately signed certificates that get generated when the container starts at start time. ALB doesn't validate validity of certificate for the property to which it connects, so it kind of makes sense. Whenever a container inside the ECS task connects to data services, we try as much as possible to use VPC endpoints. So S3, DynamoDB, we would never go over the internet. We'll try to use endpoints whenever possible. Our batch-based applications support 2 flavors. And again, I'm not advocating to use ECS for batch-based applications. You probably should use Lambda if you can. But sometimes there are use cases when you can't. So we support two trigger-based implementation. One is time-based, which supports both cron and rate-based implementation. And that one is somewhat simplistic. It launches a task. It presumes that the application or container inside the task knows what it needs to do. And as soon as the task finishes its run, it exits. And since it's the last foreground process inside the container exits and the task gets shut down. The event-based implementation is a little more complicated. It's more complicated definitely than with Lambda. You can't just pass an object of the event into the Lambda context. So there is something called event override, which you need to do for an event-based stuff. And what happens is that those overrides get injected as an environment variable inside a container. So the use case that we're using it for the most part is the S3 object put. Sometimes we receive very large objects from our partners, and we need to process this object. Lambda has a limitation of a runtime. It's only 15 minutes. So for anything that needs to run longer than 15 minutes, or you simply don't know how long it's going to take to run, this is a good use case. So Fargate is security by default. Both Akshay and Raphael had mentioned it. For us as a customer, AWS has this shared responsibility model where AWS is responsible for part of the stack, and then you as a customer, or us as a customer, responsible for the remaining part of the stack. With Fargate, we push the shared responsibility, or rather responsibility of AWS even further, so less responsibility for us, which is great. Full tenant isolation, Akshay had mentioned that, using Firecracker through hypervisor. And this is a big one, an ability to attach a task role to the task itself. You're probably familiar with instance profiles from EC2. This is very similar implementation. You can create, you operate on entitlement-based security. If you need to connect to a service, you don't worry about secrets anymore. You have that entitlement through the role. No operational overhead. There is nothing for us to patch or maintain. And finally, we are a highly regulated industry, so to have SOC 2 compliance for us is a must. We wouldn't even consider a service that didn't have that certification. But you can see that Fargate has a lot more certification than just SOC 2. It has HIPAA compliance, so if you're in healthcare, you can consume that service, and others as well. Some of them, I don't even know what they mean. So let's talk a little bit about data protection. Obviously, we have some environment variables that are sensitive. The way ECS is implemented is that if you look at the task definition in the console, you can actually see the environment variable key and value. So for us, it was extremely important to encrypt those sensitive environment variables and decrypt them only at runtime within the task that is supposed to have access to those values. End-to-end encryption in motion is a requirement. I showed you how we do it through the load balancer, ALB or NLB with TLS now, and then into the container using the private encryption from ALB to the private certificate encryption through the ALB to the task. All the certificate are issued and rotated by ACM, and all the data is accessed through VPC endpoints whenever possible. So this example here that I want to talk to you about, I'm not advocating for it. I'm just telling you what are the things that you can do. For us, it was a requirement. We had a legacy, still have to some extent, a legacy secrets management system. And because that secrets management system was not cloud native, today there is AWS Secrets Manager or Amazon Secrets Manager that you probably should be using. At the time, it wasn't even existing. We had to inject an encrypted environment variable into the container through the pipeline. And that's the way we decided to do it. So the pipeline, or the agent of the pipeline, would have an access to that legacy secret manager system, a secret management system. The policy of the role of the agent would allow it to decrypt anything with any key, and then encrypt again with the key specific to the task. Each task will have specific KMS key by the way. So it would decrypt at runtime and then re-encrypt again with the application-specific key, and then inject the KMS encrypted value into the environment variable of the task, and then the role of the task would only allow it to decrypt with the key that belongs to that task. So at runtime, the application would run, it would decrypt the value from the environment variable of the container, and then it will have access to the clear text value. Passing environment variables through CloudFormation was another interesting challenge for us to solve. You simply could do a parameter for key and a parameter for value, but very quickly you learn, depending on the amount of parameters that you need to pass through your applications, that you will run out of the limits of the parameters per stack. So we had to devise a clever way, and I don't know how clever that way is. I had some feedback yesterday that pipe not necessarily is a great separator, but it works for us, and if it doesn't work for you, maybe there is another implementation that can be done. But what we said, we're going to pass a string of key value separated by pipe, and then use CloudFormation native primitives or sub-functions in order to extract the key and the value and pass it in the right into the ECS context within CloudFormation. From the diagram before, and another thing, we have a lot of custom resources that are doing different things. For this encrypt-decrypt thing that I showed you before, we had to write a custom resource. Obviously, CloudFormation doesn't support everything out of the box. So this CloudFormation, or the troposphere section of code here, illustrates how a custom resource using a select and split built-in CloudFormation template passes an encrypted text from a parameter into the context of the custom resource, which in the next step re-encrypts it. And now that value is going to be available to ECS as an environment variable. And here is a text, a block of code of ECS environment variable within CloudFormation, where the key is the first element of the parameter, and then the value is the output of the custom resource with the encrypted, with the key of the task, value that is being passed to the ECS context. ACM is another story which required a custom resource. So when you request a certificate from ACM, it actually doesn't issue it right away. It needs to validate the ownership. That can take up to 30 minutes. Usually it's between 2 and 5. But we couldn't continue within the run of the CloudFormation until we knew that the certificate state is now issued, and we can attach it to the load balancer. Another thing, we had to pass additional names for the certificate, so it's actually issuing the same certificate for multiple names by which we can access that load balancer. And this section of the code shows you how we did it with the custom resource called ACM Domain Validator. Once the certificate is issued, it's passed to the load balancer listener using simply certificates, which returns the output of the previous custom resource output. Task roles. I have mentioned it before. It's very similar to instance profiles, even simpler to implement. It allowed us to create policies that are extremely specific to the application use case. The policy is very narrow from the access control and allows only access to what the application inside a container required. And finally, when the role is created, to attach it to the ECS within ECS task definition block, simply pass task role ARN, and that attaches the role to the task. By the way, it's done at the service level, so every task that is being spun up through Elastic events within the ECS service will have that role attached. Let's talk a little bit about infrastructure protection. So we started using a third-party tool, and there are a couple of those tools on the market. There's Aqua Security and some others. I think a couple of weeks ago, AWS announced a scan on push, so you actually can scan images while they're being pushed into ECR. Very important thing to us was to be able to protect an application at runtime. So first of all, we need to make sure that the application, or rather the container that is running within the ECS task, is one of those images that is approved, meaning we scanned it, it validated within our security policy, security posture, and only those images are running. And then if or when an application within a container gets compromised, we wanted to make sure that that application could not escape the boundary of its initial permission, some sort of an envelope around that runtime. And when compromise alerted, we wanted to get notified. And as I said before, we don't want the application to escalate its own privilege and access something that was not supposed to. So while we allow our developers to compose their Docker file and build any kind of Docker file composition that they want, we always want to make sure that the starting point, the from image from which they're building their container, is one of the approved ones, and then the entry point as a first argument has a micro-enforcer, which is that envelope that protects the application code. I did mention before that one of the most important things for us was reliability and no-ops. ECS service will always maintain a desired number of tasks running. When you deploy an ECS service, it asks for 3 numbers for tasks. One is the minimum number of tasks, which for us defaults to 2. The other one is maximum number of tasks, which for us defaults to 6. And then the desired number of tasks, which usually at initial time defaults to minimum, but it will scale up and down between minimum and maximum depending on the elastic events. There is an integration and tight relationship between the target group of the load balancer, NLB on A or ALB, and the ECS service itself. The actual health check of the tasks in our use case, while it can be done through ECS service now, we started doing it through the load balancer. And then the ECS, the service, would get a signal from a target group health check, and whenever a task stops to be healthy, or it simply doesn't respond within the time that is allocated within the thresholds, ECS will restart that task. Autoscaling is another feature that is built into our single stack implementation. I'll show you a little bit more about that. And ECS will make sure that always the desired number of tasks are running, and will scale up and down based on CloudWatch metrics. So this screen here illustrates the relationship. While this is the ECS service screen, it shows you that there is a mapping between the target group within the load balancer and ECS service itself. And as I said before, ECS will restart a task which is no longer deemed healthy by the target group in the load balancer. As I previously stated, the desired number of tasks will always be running. So here, I actually purposefully went into the service and I killed a task. And within a minute, under a minute actually, ECS detects through its loops that desired number of tasks is no longer running, and it starts a new task from the same image. Within the target group of the load balancer, in this particular case it's an ALB, you can see that there is a path for the health check for your application or microservice, and obviously the port. Those other numbers are dialed to the minimum number that AWS allows. You cannot set it to less than that. So we want to be as aggressive as possible in our elastic events. We want the applications to go into service, or rather containers to go into service as soon as possible. This is the autoscaling tab within the ECS service. While you use autoscaling service to define this, it shows you the relationship. Every time a CPU of the service, which is all the tasks running at that time, goes above 35%, we want to bring another task. Again, it will scale it up all the way to the maximum defined in a container definition. And then when the CPU in the service drops below 5%, we want to remove one task, and it will continue removing until we are at the minimum. We'll never go below that. We use CPU utilization as a metric for scaling. There is memory utilization metric that is available, and obviously you can do your custom metrics. And one more thing that I wanted to add here is that those settings are also set to the most aggressive possible within AWS. You cannot actually make it less than that. We tried. So what are the next steps for us as far as our journey with ECS Fargate? This is not on this slide, but our first idea was that we would deploy a stack of ECS cluster, which when you run in EC2 mode is kind of relevant because you have your EC2 instances attached to the cluster. When you're in Fargate mode, it's simply a namespace. It's a separation, and it doesn't cost anything. So we're actually creating a cluster per microservice or application that we deploy. Within that stack, there is obviously an ECS service and the tasks and the application load balancer. What we learned after a couple of months of implementation is that it actually takes time to deploy this stack, especially the load balancer. It takes a couple of minutes to provision, and then everything needs to be done. The ECS components are not as expensive from time perspective, but it still takes time. So we decided to separate the stack into a couple of components. We have a notion of persistent stack where the load balancer is in a persistent stack and ECR is in a persistent stack. And then what we do at the elevation is actually just changing the image in the task definition. And we use the same load balancer for all the versions of the same service. So when we elevate blue-green, we simply point to a different the same path points to a different task definition, which would have an elevated image version. The other limitation there is that when you deploy, like, it seems really cool, but when you deploy all those stacks, you actually consume a lot of IPs. IPs for application load balancer for each version, IPs for ECS task. It's all kind of removing from your VPC subnets scope. And this new implementation actually reduces that consumption. We also created subnets that we call outbound only. They're kind of natted subnets, not the greatest implementation, but when you run out of IPs, you need to be creative. And then the tasks are actually going into those outbound only subnets because they only make outbound connections. The connection into them comes through load balancers. So we really want to, that optimization, because now we don't have multiple ALBs and they're not cheap. We have one ALB per all the versions of the same microservice. That reduced the cost somewhat. Sizing the task to the sweet spot is extremely important. We have had traditionally somewhat CPU-hungry applications. To rewrite those applications, to optimize them so that they consume less memory in CPU is something that is extremely important to us. And through that, we actually reduce the size of the task that is requiring to run those containers. So that's something to consider. Fine-tuning autoscaling for cost, as I said before, ours is configured to the most aggressive possible. Maybe we'll stay with that, but maybe you don't need it in your non-production regions. So every autoscaling event costs you money through deployment of more Fargate tasks. If you don't need this, consider reducing it. Reducing Docker image size will increase elasticity and reduce cost. One, because you're actually storing a smaller artifact in your ECR, and you do pay for gigabyte storage there. But also, the smaller the image size, the quicker the service can pull it from the repository and then put it into, and then run what's the application inside it. So your elastic events are happening that much faster. It was just announced with AWS savings plan and reserved instances or reserved commitment plan that was announced. We definitely want to implement that. That will reduce our cost. And for the most part, all the optimizations are around cost, which is kind of like your maturity, right? Like you implement something, it's running, and now you're trying to get it for less money. Experimenting with Cloud Map, you can actually send traffic to ECS tasks, which is just IPs within your VPC, through Cloud Map. It doesn't have to be an ALB. And the more you start exploring with AppMesh, that becomes a lot more of a viable option. It can stand on its own. Unfortunately, there is no way for you to attach ACM certificates there, so that's an area for consideration. Obviously, we want to implement AppMesh, and hopefully the service matures and gives a lot more functionality, hopefully tomorrow. And we definitely will experiment with it. Service-to-service calls can be a lot more secure. Prepare for the age of sidecars. I think every vendor on the market today has a sidecar. What happens is that when you daisy chains those sidecars, you actually create a train because everyone waits for another, and the elastic event of your application, the logic which is pertinent for your customers, takes that much longer to go into service and actually give value to your business. So don't forget that. Well, it's easy to implement. It might have some issues. Integrating with other AWS services, I think AWS is constantly giving us more that we can integrate with. We have some application intelligence tools in-house, but we do want to look at AWS X-Ray because through the role you can do a lot more. There's not many more things needed. Container insights were rolled out a couple of months ago. We're definitely taking advantage of that. And then finally, anomaly detection is another feature, which is everything NML can do for you and you don't need to do anything for it is probably a good consideration. And with that being said, I want to thank you for coming today and listening to us. And if you don't mind, please complete your session survey. And if you have any questions, please stop by and we'll be happy to answer them. Thank you so much.
Thank you.